Welcome back, fellow chemists. This is part 2 of Unit 5. We're going to cover some of the characteristics and properties of the periodic table, and especially some patterns that we see on there. Now, one important detail that we really need to distinguish is metals from nonmetals. I know that in the last section we talked about metals and how they conduct electricity and they are giving up electrons. Of course, the nonmetals are the opposite. They're removing electrons from the metals, and they don't conduct electricity because they are taking the electrons. And a lot of this has to do with the size of the atom. So we're going to go down to this chart right here, way down here in my notes. I have something that looks like this. So if you look at the peaks of this graph, those represent all of the elements that are in the first column in the periodic table. And the bottom ones, if you look those numbers up, those match the elements that are on the very far right side of the periodic table. So just to go back to a periodic table for comparison, if we look at it in a different way, this might look kind of confusing, but this is a three-dimensional view of the same thing. And these elements down here, as we go down this direction on the periodic table, they get much bigger. And it's just kind of common sense. Hydrogen has one ring, lithium adds another ring. As we keep going down the periodic table, we are adding yet another ring to those elements, and they're becoming bigger and bigger and bigger. Now, the part that's hard to explain is that as you go this way on the periodic table, they are actually getting smaller. The numbers on the periodic table are of course increasing, but the actual size of the atoms are decreasing. And that has to do with the magnetic pole or the electric pole of the protons and the electrons. So for example, hydrogen has one proton and one electron. We're going to kind of ignore the neutrons because they're neutral. And helium over here has two protons and two electrons. Now, it wouldn't seem to make much of a difference, but if you think of those in terms of magnets, attracting one another, opposites attract, well, helium only has two magnets, a proton and an electron pulling themselves together, whereas helium has two magnets, a little bit more magnetic strength from those electrons and protons pulling together. So that kind of makes helium more compact. So every row like that, every period on the periodic table gets smaller and smaller and smaller as you go to the right on the periodic table, because you're adding more and more protons and more electrons. Now eventually, when we get to, say, neon, we have too many protons and electrons to fit onto that second ring. So we then go to the third ring, or the third level of the atom, and we add more protons and more electrons, which makes that atom more and more compact and smaller. So for that reason, let me erase all these marks, we have the smallest atom on the periodic table up here, and we would have the largest atom, francium, down here. Now it might be tough to compare two that are right next to each other diagonal, but having an extra ring, of course, makes it much more reactive, much larger than one that's only on the sixth ring. So it'll be larger. All right. We'll pause there. Now, two more trends that we have that are quite similar are electronegativity, which this graph shows. And you can see that the low number is down here by francium, and the high numbers are up here by helium and neon. The other pattern is this one right here, ionization energy. And here's one that has ionization energy. You can see that the atomic size or radius kind of goes along with the ionization energy, which kind of goes along with the electronegativity. So I'm going to go back to electronegativity because that one was, at least had some numbers that we could refer to, maybe a little bit simpler to look at. So down here, francium. I'll highlight it This one has the lowest number. Whether you're talking ionization energy, electronegativity, it has the lowest number. And that's because it is the easiest to steal an electron from. First of all, it's the largest atom, so it has electrons that are easy to take from. And second of all, it's in the first column. It wants to lose an electron to feel like a noble gas. So it's super reactive and super easy to remove an electron from. Now up here, I guess fluorine would probably be one of the best examples to use. It's very easy to steal, I'm sorry, the numbers are very high. This is very hard to steal an electron from because fluorine wants an electron. It wants to be like the noble gases. And it's very small, much smaller than francium. It has less rings. And of course, remember as we go this way on the periodic table, those atoms get smaller and smaller and smaller. And it makes sense that it's tougher to take electrons from something that's smaller. The nucleus has much more control over the electrons because it is so small. Whereas francium over here, it has less control over its electrons. It has 1, 2, 3, 4, 5, 6, 7 rings. So its rings are farther and farther away from the nucleus, giving the nucleus less control over its electrons, which again works out perfectly because francium would much rather lose an electron to be like the noble gases. Now these noble gases, remember, they're already perfect. They already have the exact number of electrons that they want, so their numbers are generally going to be higher to begin with. They don't want to lose electrons. So of course fluorine's number is high, but neon's number is even higher because it certainly doesn't want to lose any electrons. So pause there. So as you can see, the size of an atom really has an awful lot to do with how reactive it is and what it does with other elements. Now here's a chart that shows how its charge has to do with its size. We know from the periodic table that fluorine is quite small. So we've got fluorine over here. But when it becomes negative, it becomes a little bit larger. It goes from this number to this number. So nonmetals want to become larger when they steal the electrons that they're trying to steal. Metals, on the other hand, when they become positive, they become a little bit smaller. So they lose some weight. They tone down a little bit. Metals want to lose electrons to become smaller. Nonmetals want to gain electrons to become bigger. And of course, the ultimate goal is for all of them to feel like noble gases. So this all explains why metals conduct electricity. Metals don't want electrons. If you send electricity through a metal, it will pass all of those electrons on because it doesn't want them. It wants to lose electrons. It wants to be like a noble gas. Plastics, nonmetals, on the other hand, want to take those electrons. So that's why if you have an extension cord, the outside covering is plastic. It will take the electrons. It will make the wire safer. The inside, the core of the wire, is metal, and it will pass electrons on from the wall to the appliance that you're trying to run. So now that you learn a little bit about the periodic table, hopefully you can add a lot to your notes and do several review questions. If you go onto the documents section that you've found this video on my website, you can also do several practice problems and determine the different elements, such as the largest element and the smallest element, and what that means to be the largest element and the smallest element. So thank you much for watching, and we look forward to the next unit's notes.